so here we are on what are we? May 9th, 2023 for the Ambassador Briefing. I'm James Melton, Chief Ambassador of the Mars Society. And there are several things coming up shortly that you'll be interested in. And a lot has happened in the last month since our last briefing. One of the things that's coming up, of course, is our standard third Tuesday of the month Red Planet Live podcast with Ashton Zeth. And this is going to be an exciting program coming up on the 16th, 5 o'clock Pacific time and 8 o'clock Eastern time. It'll be about an hour, and James Burke will be on board. He'll be finished with the Crew 261 MDRS in Utah, and he's going to give a description of what happened, some of the experiments that we're working on, and how things are going along with the MDRS. And we were going to have something today with Roger Gilbertson, but we'll move that to next month, and that'll be in June. So I'll alert you to that as well. One of the things that I thought I'd start out with was the rapid unscheduled disassembly. There has to be a bit of humor in there somewhere. Those who thought about this Rudd experience for the Starship. I've jotted down some notes here that I'd like to share with you. And one of the reasons I'm doing this is because we want to keep our information consistent and accurate when we're going out there and delivering information to people. Sometimes it has a bit of a chance to get convoluted. So I did a little research. I believe this is accurate. If you find any variance in what you know to be true, please share that with me. So the April 20th, 2023 Starship launch, and what they're referring it to as the rapid unscheduled disassembly. All right, I'll explain that a little bit later. It was 4 minutes of flight time, 4 minutes of flight time. The altitude was 39 kilometers, which is about 23 miles. The speed was about 2,150 kilometers per hour, which converts to about 1,300 miles per hour. And they had a AFT, which is an automatic flight termination, which was activated. And that actually was the RUD, the rapid unscheduled disassembly. And the reason it happened, let me read through some of this here. There was a slight tilt of an angle on liftoff, which altered its trajectory. 3 engines were intentionally not started. They did not fail to ignite. They just were not started, leaving them with the bare minimum thrust for the liftoff with 30 engines. The 3 engines were not healthy enough to reach full thrust. And at T-minus 30 seconds, a mini rock tornado is what they're calling it, explosions subsequently occurred, causing large chunks of debris to hit several heat shields and causing them to fail. There were probably 3 or 4 heat shields that were missing. But it may have also, they may have discovered this by now, but they may have also kicked up some concrete and hit 5 of the engines, because we only had, I guess there were 8 engines that were out. And they believe that may have happened at liftoff. And T plus 27 seconds into the flight, we lost communication due to some mysterious energy event. I don't know if they've discovered what that is yet. They had a hydraulic failure, and the next time they're going to use electric thrust vectoring. Of course, that's the gimbal engines and how they maneuver themselves direction-wise to change the trajectory of the vehicle. So a total of 8 engines were lost. They did reach max Q, which is the maximum dynamic pressure, and they had 4. This is a plus here. They had 4 fully controlled loop rotations to correct itself. So those were actually being controlled by the rocket itself, but they couldn't get it back on track. Now, they think one of the major reasons they had these problems was because they were taking off on a concrete pad. Now, Musk, being very optimistic, thought he might be able to reschedule another flight in 1 to 2 months, but I don't think that's going to happen, and neither does FAA. It's more like 2 months to a year. Now, there were window breakage. There was window breakage 6 miles from the site and some cracks in buildings. So the FAA is going to want to monitor this very closely for safety reasons. And that will be the major delay in getting FAA approval to do another orbital flight. The Raptor engines, for statistics, is that each one of them has 510,000 pounds of thrust, and a takeoff with all 33 engines, there's 16.7 million pounds of thrust at liftoff. No wonder it was breaking some windows. The path to usability is paved with trials and tribulations, and the tower remarkably remained unscathed, which is amazing. So the plan is, to wrap it up, they want to start the engines faster to get off the pad in 5 or less seconds for the next go around. And they're probably going to use a very thick steel plate for the pad with extreme water cooling. Musk says there's an 80% chance that we can do this by the end of the year, or 100% chance within 12 months. Does everyone have that information in their minds? And do you have any corrections or thoughts on that? Anybody? Bill. Bill, you're on mute.
Got it.
There you go.
Yeah, let's see. I've been following pictures from the rebuild every day or two. There's many journalist operations have spy cameras down there, and there's a guy who does flybys in a Cessna every few days. The metal plate with the water looks like an upside down shower deluge system. So it's perforated flat metal plates. We've seen the segments on the ground. They're very easy to see what they are. The water tanks are already there. It's not a huge, tall water tower like everybody else has. They're doing it with pressurized horizontal water tanks. So it should have the same, or it should have the flow rate that it needs. Yeah, there was a miscalculation for sure in the strength of the concrete. Yeah, Ron, could you mute yourself? You end up taking over the screen. So anyway, the 3 engines that were not used for takeoff actually ignited and were shut down by their engine computers. It's very, very hard to start a rocket engine. And these engines have all been pre-tested, so we know they start. It's just in the presence of a huge acoustic reflection from the concrete that could have upset them. So people compare this way too much to the Soviet N1 that had 30 engines. The computers are much better. The plumbing is much better. The CAD designs and simulations are all super much better than the Soviet time. The Soviet era couldn't even do static fire to pre-test their engines in the N1 launch vehicle. These engines in serial number 7 booster were all pre-tested. The other thing is people criticize the number of engines. Why 33? Why not just, if you need double the thrust of a Saturn V, why not 10 F1 size engines? And the reason is engineering trade-off. In the trade-off space for engine thrust, 500,000 pounds. I mean, Elon originally was targeting 1 million pounds per Raptor, and they optimized out at 500,000 pounds per Raptor for many, many reasons, not just thrust efficiency, thrust to weight ratio, of which the Raptor engine is a huge winner, but also ease of manufacturability, ease of testing, ease of transport from the factory to the test site in McGregor. Ease of refurbishment, ease of replacing an engine on the stand. You don't want a 4,000 pound engine when a 1,000 pound or 900 pound engine will do, easier to swap out. You don't want it to optimize out too low, like a Merlin size 200,000 pound thrust, because then you have 60 engines, and that does get to be a plumbing nightmare. But every engine has a titanium shield from its neighbor, not around the nozzle, but around the rotating parts, which are the turbo pumps, the most popular thing to explode.
Yes.
But anyway, I think that's enough detail. We think we'll get a pad repaired within 2 months. I say we way too much, but I run the Facebook group, so I
No,
identify.
that's good. We appreciate your insights, Bill. There's a lot of detail there, and I hope you've been taking notes. It's easy to get this information digitally confused. So when we're out there expressing and sharing our thoughts about what happened, one of the reasons I bring this up is because you noticed on all of the networks, the Starship exploded, and but a lot of that explosion was self-inflicted, and this is a great learning opportunity. What I like about what Musk does is he tests and he flies, he tests and he flies, and then they make their corrections. So it's a little risky dollar-wise, but that's what they're doing. So, all right, we have
it's not a rocket, right?
Pardon me?
They're launching a whole rocket.
Who's talking? All right, well, let's put someone on here who we know is talking, and that is John Ratliff. I see your smiling face there, John. Are you in Dallas today?
No, I'm outside of Austin today.
Oh, outside of Austin. Okay. Well, John has graciously offered to step forward today and shed a little insight on some space spin-off technology, along with his concepts of how we might knock on the door of some potential clients to present your work, to share a little bit about what the Mars Society is about. John, do me a favor. I know you're a geologist, you're architectural engineer for a variety of purposes. Would you share just a little bit more about who you are and what you're going to be talking about, and just jump in there and let us hear a little bit about your words of wisdom?
Sure. I'm really have been more of a technologist most of my career. I did have get a degree in geology, and spent 15 years in the oil and gas industry before making a jump over to IT technology. So one of the things about that is that you have to be constantly learning new technologies and applying those. And as a technologist, I worked for some of the largest vendors out there: Sun Microsystems, NetApp, Hitachi Data Systems, and Dell EMC/VCE. So a lot of these integrated companies, and one of the things you had to keep track of is the constant rate of change, or the increasing rate of change, really, from technology and being able to adapt those to new solutions. In fact, one of the things my wife and I have been doing since our kids are out of the house now is going through and cleaning out old tech that doesn't work anymore. And it doesn't work not necessarily because the hardware failed. It doesn't work because the software isn't there anymore. And you just can't run some of this stuff because you can't get the drivers are not supported and that type of thing. So, it's been a fun career, and really what I'm looking to try to do as part of this Mars Society ambassadorship is see if I can apply some of those skills and technologies to a new career path, maybe, or next phase of my career, and help some of the young people out there that are in high school and college to jump into the STEM technologies and provide some of the manpower that's going to be needed to fill some of the gaps. One aspect of that Jim and I were talking about earlier was the fact that a lot of these kids in high school are pretty intimidated by the current astronaut corps. Most all of them have PhDs or multiple PhDs, in fact. And for a kid that's in high school, just looking at a career in space technology, that seems a little overwhelming for them at first. But part of our job is to help folks understand that you don't need to necessarily have a PhD. There's going to be lots and lots of job opportunities, career opportunities to get into the technology space associated with space science that don't necessarily require an advanced degree. It may be as simple as running cables and wires in a rocket body. So, other things include construction stuff like what they're doing with the pad on near South Padre Island for this Starbase. But one of the things we wanted to also do is talk about some of the materials science and the spin-off technology that's associated with space technology. And just to continue the conversation that we were having about Starship, one of the designs that they had for the pad was to give them an opportunity to launch this thing close to the ground and really see what the results would be, because you got to keep in mind that the Mars Direct program has a Starship, for example, landing on Mars without a launch pad. So if we're tearing up and excavating a huge hole underneath the rocket now, what's it going to do to an unreinforced landing spot on Mars somewhere? So this is actually very educational all the way around, and there may be some iterative feedback on how something like that might land on Mars, rather than just using all of those Raptor engines to land on an unprepared surface. So obviously there's got to be some modification of the design, possibly even the mechanics that are associated with landing and taking off again from a Mars location, and what implications that has for the design moving forward. Anybody got any questions on that? I mean, that's a pretty significant aspect that nobody's really talked about with the whole excavation at Starbase with the recent launch.
I think we're pretty clear on it, or at least confused on it, but thank you for that. Bill was very thoughtful in expressing his feelings. I see a few questions here on the chat. There are 33 Raptor engines. One of the questions was that. And I think Thurston, I hadn't heard that Rudd was digging. I think it was rapid disassembly, but
yeah, can you hear me?
Yes.
Yeah, no, that was just Scott Manley came up with the term. I mean, of course, it was a disassembly, but as a joke, it was a rapid unscheduled digging because of the crater the thrust created.
I understand.
So
Okay.
I find that kind of hilarious.
Yes.
It's more like a joke.
Yeah, okay. That's fine. We need more humor in today's world,
Yeah.
that's for sure.
Yeah, I mean, Scott Manley is great for that. I mean, his videos are awesome.
Yes. Yes, that's I'll bring that up. I'll bring that
Yeah.
up. That's excellent. All right, then John, you're on for your other portion here, and we're eager to hear some stories about your space spin-off technology knowledge, et cetera, et cetera.
Yeah, so let's dig into that just a bit here. We've got again, starting with Starship, some of the spin-off technology has been really around materials science. Starship's using stainless steel as its primary rocket body technology and materials. That's also what they're using for some of the fuel tanks and other components. One of the reasons for that was to reduce weight overall because they don't have to paint it if it's stainless steel, and then correspondingly, we've got other companies like Rocket Lab who are using carbon fiber for their rocket bodies. And again, this is just an example of some of the spin-off technology which is being used, and this is also applies in other areas. So we'll see more with the printing technology, 3D printing technology. I forget whether it's Firefly or one of the others is using 3D printing technology to actually build their rocket bodies. And the same type of technology is being investigated as a spinoff to build habitats from stuff that's similar to lunar or Martian regolith. So these are technologies which are also applicable here on Earth. If we can get this technology developed so that we can 3D print a home for somebody, that's another advancement that's a spinoff from the technology directly.
And 3D food printing too.
Yeah, I'm not so sure about that, but we're doing a lot of strange stuff with food these days, aren't we?
Yes.
But a lot of foods are actually 3D printed to be more serious about it, whether it's potato chips or chocolate candy or different stuff like that. I'm not so sure about proteins and other things that's with this whole non-meat substitutes, but I guess the jury's out on those concepts. But I wanted to talk about some of the different technology areas, and I'm going to refer everybody to a company called Seraphim Capital. If you want to take a look at their website, they've got a space tech map that they do, and the last one I saw was from 2021. But they basically have technology broken out into 6 major areas for space industry. So you got the folks that build space hardware, and I'm looking at a different screen to make sure I hit all the points here. Space hardware and other componentry and engineering to build whether it's launch pads or habitats or anything like that. You've got the actual launchers and launch services, which also include flight and delivery services. You've got space tugs that will be coming out there, might help with some of the orbital debris that's out there that needs to be cleaned up. They've got the data analysis, data collection that needs to be done, whether that's from satellites themselves or by drones and unmanned aerial vehicles. That's a huge amount of data that's being collected. And then those would all be kind of considered upstream areas. So that's before you really get into flight. Downstream is once the vehicles are up in space, you've got the downlink communications, you've got ground terminals, security and storage, and then you have to analyze all that data as well. So we've got the data coming from the satellites, drones, and UAVs. That all has to be analyzed. And one of the hottest jobs in the market right now is as a data analyst or a data technologist. And those are fetching six-figure salaries in a lot of cases from private companies. And then finally, you've got the different data platforms. I'm sorry, somebody have a comment? Nope. Finally, location and mapping. These are final products that are currently for sale today. And then once you get way beyond Earth, you've got the space exploration and resources. And we're seeing some of that start now with the touchdown on different asteroids and potential mining operations on the moon. I know China has taken a big leap forward in some of that. We just recently had a private company try to land a lander on the moon from Japan, and then all the infrastructure that's going to be associated with that. So these are all areas that are going to require, just like we're seeing with the launch technology with Starship, all of these are going to be iterative processes. There's not going to be a right answer from the get-go for any of these, and we're going to learn a lot as we go, especially around with health and human aspects in space. You know, what are the real solutions to taking microgravity out of the equation as far as health concerns go, and bone loss, stuff like that. These are areas that have not really had a full amount of research into them, and we really won't be able to do that until we've got permanent habitation up in space. So yeah, those are just some initial thoughts on some of that. Anybody want to have some add-in discussion on any of those points?
I was just curious, John, was that landing successful on the moon?
They lost communication right before landing, so the assumption is that it must have crashed on landing.
Okay.
They were about 3 meters off the surface when they lost telemetry.
Yes. All right. I'm just looking at some of the chat comments here. Jump in, anyone that you want, if you have something to say. But Robert had mentioned a follow-up on John's comments about introducing the space programs and the activities that are going on in the world of space to the young people. And Robert's working on a game strategy. Could you share a little bit about that, Robert? Robert, take yourself off of mute and just give us a little thought on how far along you are on that space game.
Well, my background is created one of the first simulators, World War II flight simulators on the internet. And it was actually pretty realistic in flying. You had to really learn to fly before you can do air combat. I mean, it was so realistic that I was able to present to the Pentagon this theory back in '97 that you can do that. And I actually had shot down an Air Combat USA, shot down a U.S. Air Force captain twice. I beat him in a dogfight. So they were pretty amazed at my flying skills, and I've never jumped, I've never been in a real aircraft. But these kids are learning, the games that we're putting out there, these zombie killing games, and they're just, they're learning, they can learn things. But I feel if we do like a Mars simulation game and do some of the things that we will be needing to learn on Mars, and even having some AI NPCs that can learn and help NASA in a sense, because there's going to be these, for all intents and purposes, robots there that are going to help the humans and when they're colonizing and such. And maybe that's in one way with the simulation, we can train them, or at least get some AI training into them in a simulation type of environment, and put years behind this simulation. I'm just at the beginning of getting sort of the content. I want to get more content. I want to put some real vehicles that we'll be using and place it like 20 years in the future and how it's going to be. So some of it is going to be, it's going to be a little bit out there, but not too far out there. But I want kids to get used to using robotics, capturing smaller asteroids, maybe they're doing mining on on one of the Mars's moons or something. You know, we don't know where we're headed on this, and we need to look at all aspects and look at what's even there underneath, you know, in the geology of Mars and the moons and the asteroids, and see what materials we can use, because, you know, we're not going to be transporting all these materials from Earth. We're going to have to use what's out there, and there's plenty out there. So, and that's basically it in a nutshell. I just think that these kids, if we can get them excited about other things than killing zombies, you know, they're pretty sharp. Kids are really sharp. They have great minds.
They really are. Yeah,
We just
they
need to
are.
focus them.
Yeah,
Yeah.
they are, of course, our future. I see that Emma wrote something here. I'd like to talk with her just a moment. She said, to touch on your talk, John, Steve and I are heavily involved in data analytics for the buildings industry, which is also relevant to space technology, as you mentioned. Would you like to elaborate a little bit more, Emma, on you or Steve, your husband?
Yeah, sure. Thank you very much, James. Yeah, so just to mention that Steve and I run our own business called Phantom Factory, and we support companies around the world in the sort of construction, engineering, data industries, all about smart buildings. But we enable them to handle and process data analytics for living spaces, for temperature control, for water pressures, for engineering equipment to operate. And data is just fundamental to everything. And just to add to the points from earlier, which I think even you mentioned, Bill, but you know, it doesn't take geniuses to necessarily get involved, right? You can do all sorts of different job roles in the space industry, in advanced technical industries, in engineering industries, and it takes everybody to get involved. Data analysts, as you mentioned, John, charge a huge amount of money, but you can do data analytics at any level. And what we're very keen on doing is not only helping these huge companies, like we get involved with people like Siemens and Lockheed Martin and everyone all the way down to small one-man bands who are trying to outfit maybe a chain of coffee shops to monitor what the comfort levels are in a chain, right? So it's all about environmental social governance. It's all about proving your carbon footprints, but it's the same technology that we'll be using out when we're on Mars, monitoring our living spaces out there, and people can get involved now. So we're very keen on promoting space tech, Mars, the colonization of Mars to adults. We don't just want to help with STEM for children. I mean, we are getting involved in that as well, but we're also getting involved in STEM education at the same time as we're doing software development services and data services, because we're realizing how many people just don't understand what they're doing. So that you've got all these adults working in these careers, and they don't quite understand what this data modeling is, or why they're looking at data analytics in the first place. Maybe they're engineers for so many years, and now they're being asked to look at computer systems for the first time. So we've kind of split our business to encompass education. So we're very much going down the e-learning route as well. And we want to help adults to get involved, because it's going to be adults now that can help support and propel as we're all sort of preparing the children, the next generation, to go up there to Mars. But there's a lot people need to do now. Sorry, Steve, did you want to say something? Oh, okay. So anyway, that was my soapbox rant, but
no, that's
very passionate on a lot of levels.
Thank you. Do you find that the people that you're speaking with are more interested in your own personal delivery? Or I know you have some training sessions on video and computer. What's the best way, do you think, to open the door to the world for the Mars Initiative?
I mean, let's do everything. So the e-learning that we've produced, it's completely digital. So you can go in and log into a website in your own time. And I feel like that's a much more inviting step for a lot of people who don't want to be pressured. They don't want to be under that pressure of somebody in person, but it's a good like opener. So you can have this sort of low level education out there as a taster, and people can go in their own time and decide if they like it, if they want to know more, if they want to try a little bit of analytics, try a little bit of data modeling, and then they can go and seek further sort of help. They can go down the routes of, oh, I want to go find a course on this, or I want to go and attend a conference, or I want to come to the Mars conference later in the year. And I think people, though, you've got all sorts of learning types and all sorts of personality types, and I think having lots of approaches can only be good.
Excellent. I'm curious, are you you and Steve close to Steve Wyatt in England? Do you know
I
each
know
other?
the name, but I'm not sure why.
Okay.
I'm in Malvern, so
Oh, Steve, oh, you're on the chat.
yeah, I'm
You're
here.
in the Malverns. Oh, fantastic. Well, I'll talk to you.
I just thought if you didn't know each other, it might be a good idea to connect.
Fantastic.
That would be great. All right, Andrea. Hello. You're finished
Yes,
finished with your tuna
I
sandwich.
finished.
You
Do I have anything in my teeth?
no, you don't. That's fine. You look beautiful. So where are you in your ambassador ambitions? Are you considering them?
Well, I'm listening to what Emma's saying, and I'm really thinking deeply about it because last fall I actually did a lecture for the engineering department at JPL on I'm just an educator, just haha. I'm saying that in a sarcastic way, but I'm training the future Martian colonists, maybe the first generation that'll be off planet, extraplanetary species, pretty big. But this is what I'm doing. I'm teaching, but I'm training these kids from kindergarten up through high school. So I started thinking about what Emma was saying, and there's definitely a pipeline that I wish it was more structured. I wish I could have more contact. I do have a lot of contact, but I wish I had more contact with the proverbial rocket scientists and the engineers and the people that work in the space industry, so they could actually work on a map type of a game plan for me to follow. I just intuitively created curriculum for these kids. With catchy titles like Train Like an Astronaut and all this stuff. But I'm just kind of doing it. I'm a lone wolf. I work for myself. I research and create my own curriculum. I interview people in the industry. I have a lot of contact with astronauts and engineers and all sorts of very, very interesting people. But I'm kind of out there by myself. So I wish there was more of a defined pipeline where I could actually really encourage kids. I mean, there's this talk that I do. It's called "Is There Space for Me?" which is a double entendre. Is there space for me out there in the industry? And I go out there and I try to make it inclusionary. Of course, I want to include everyone. You don't have to be an astronaut because you're in the industry. Doesn't mean you have to be on that. You don't have to be a pilot or some high-ranking military person. Like when I was a kid, there were certain requirements to even consider going into training to become an astronaut or even a candidate. And it's so different now. There's the sociology aspect to it, the human aspect of it, because we're going to actually be colonizing now. This isn't just exploration, landing on the moon and coming back, but colonizing, long-range trips to Mars. There's a lot of different kinds of people we're going to need this round.
And I'm glad you brought this up because this is one of the purposes for the ambassador program, Andrea, is to gather minds like we have on the screen today and bring our knowledge together. And although this is a rather new program, we're about ready to really take it by the neck and bring the people together with a more consistent idea of how to deliver this information to the public. I'm looking at Dean Arvidsson sitting there in front of that beautiful sunset. And Dean, you have been a teacher, a professor of physics and astronomy for what, 25 years. And maybe you would have some thoughts either now or later on designing some kind of a curriculum or adding your insight to that. Is that something that you could foresee happening?
Sounds good to me. I don't have any immediate thoughts about it. You know, the one thing I know is there's a big push in NSF, you know, the National Science Foundation and NASA. They fund educational programs at the universities and the colleges. There's something called REUs. Some of you may know about those. Are research experiences for undergraduates, and we had one at LA City College. And anyway, you know, our program, we paired our students with the astronomers and engineers at JPL, the Jet Propulsion Laboratory, and several of them worked on Mars-related research and Mars-related projects. And you know, but there's a lot of push for education. Sounds like that was what the topic was, and I think it's great. I don't know. I don't have anything else to share at the moment regarding that.
No, that's fine. I think that we need to get some kind of a basic curriculum, not to make it too convoluted, but just some kind of a way that we can. We have videos, of course, on the Mars Society website, all that we can connect with and use portions of in our presentations. But getting a plan of doing something. Now, I shared this with Nasser earlier. I was very impressed with what Nasser did from Pakistan. Wave your hand, Nasser, so they can see who you are. He sent me about a 9-10 minute video of his plans, which I'll be sharing with you in a briefing wrap up of this particular talk in the next email, about a 10-minute overview of what his plans are for 2023. And very well outlined. And then he shared that with me, and I would like to share that with you as well, because we can all learn from one another. And you, Emma, and you, Steve, also husband and wife working on this project together. Anything that you can share on opening doors to the general public? Of course, our mission is to gather a professional team of people and dedicated to elevating the awareness of the space program to the general public, of our mission to land humans on Mars in this decade. So with that in mind, just arbitrarily doing things is okay, but if we have a focus on doing this and how it's to be done, I think it makes a lot more sense. It's kind of like you have two magnets here, or excuse me, two pieces of metal, and one is magnetized and one isn't magnetized. They both are the same size, the same shape, the same weight. They both look alike, and from all outward appearances, they're identical, but one is magnetized. Maybe with a neodymium magnet, I'm not sure. but the difference between those two magnets, the magnet and the unmagnetized, is simply the magnetized particle has a focus to it. It has a power, it has an organization, and it has a direction, and it has the ability to bring things to it and repel things. Whereas the other, the atoms are just going hither, thither, up and down, to and fro, scattered. So the focus is an extremely important part of what we're doing, carving out maybe an hour a day, and conceptualizing on how you can deliver this information. Who else has some input on this aspect or want to reflect a little bit on what John Ratliff was talking about regarding space spinoff? Who else has some thoughts without having me call you? Go right ahead, Dean. Dean.
I'm really enjoying the meeting and all the discussions and everything people are sharing here. I had a rather specific question, revealing my ignorance of these topics, but John Ratliff mentioned something about the RUD and how actually they, Musk and the team are learning quite a bit about the Starship and about the launch and everything. And I thought it was interesting, John, you said that when we get to Mars, we would be, the idea is that the sounds like the Starship would try to land on Mars and then take back off from Mars. And if that's the case, my question is there any thought about building a landing pad on Mars that instead of just landing on the dirt? And do they have the ability to land something, that accurately in a relatively small, on a relatively small landing pad? I'm just curious whether anyone knows anything about whether that's being explored, or Bill maybe have some information there, but anyone?
Yeah, Bill, talk about the tower.
Yeah, they right now on Falcon 9s, they can land within 3 meters. They have GPS on the drone ship to go to a particular spot. They have GPS on the returning Falcon boosters. They don't communicate to each other. They just agree to meet at a certain spot in 3D space. SpaceX has recovered successfully now 189 Falcon 9 boosters. People didn't believe it when they did the first one. Now it's done 188. Incredible savings for reuse. On Mars, the two things that save you, two things that save you, the gravity is lower, so you don't need full thrust. There won't be a booster on Mars. There won't be a 33 engine. They could take off maybe with 3 Raptors. Also, the Starship, by the time it gets to Mars, will have legs. So perhaps it'll be easier to land. Now, we landed on the moon without a prepared pad. So, and it's hard to put down a robotic. I mean, we hope to have a robotic methane and propellant factory before, we can't send a Starship and it'll arrive empty with the architecture the way it is now, without the return fuel already being manufactured. So we need ISRU for getting the return propellant. But yeah, the Starship that's going to land on the moon for the Artemis program, the HLS part, won't be using the lower booster, the lower nozzles at all. It'll have probably higher up, smaller thrusters to land. So they'll be a couple hundred feet away from, or at least 130 feet away from the surface.
You make a good point there, Bill, about the tripod landing. That's certainly in the picture. The other point I brought out about the tower that grabs the vehicle itself. Ultimately,
that's an absolutely audacious way to save mass on the booster right? The booster should be reusable within hours, maybe less than an hour, because it won't be landing on a pad. It won't be landing with legs at all. Save the weight of the legs. It'll come back in the vicinity of the launch tower, which has huge chopsticks that will catch it out of the air.
Any other thoughts on the landing issue or anything else we've discussed today?
Dane had brought up aspects of pre-prepared landing pads on Mars, and some of the images and graphics I've seen from SpaceX themselves have included the graphics with a prepared landing pad on them. However, the first few landings aren't going to have anything waiting for them, so it's going to be interesting to see how they deal with that aspect of it.
Okay. I'm looking at here the question from Emma. I have a further question. Let's see what she says here. Of the group, Mars ambassadors, do you feel we're all trying to educate different groups of people at different levels? Would you perhaps find it easier if I were to, if there were a central educational site we could all use to provide basic induction level of training first? I'm thinking about Mars Ambassador website, openly available, and a basic level of education content and videos to start a pipeline of learning. This is an excellent idea, by the way, and helping us to pick up further education with our own methods. Interested in any thoughts? That's some excellent thoughts. We could have a dedicated site on the Mars Ambassador, on the Mars website itself. Let's see, agree the need for Emma. Okay.
Yeah, I know that I've been speaking to James Burke about this for a while anyway, but I know you guys are so busy. But I was just curious to see what the need was from the group. If you had basic induction level training. I know Bill, you kindly helped us with our we've already got a public education course out there, which some of you have already seen. But that was just a sort of taster, an initial foray into the whole.
Yeah, you're touching on a point that might become quickly political, because NASA has a lot of resources. NASA has a lot of web information. Sadly, it's all on the NASA architecture, which will get us maybe flags and footprints on Mars in 50 years, 40 years, right? There's PowerPoint architectures up the wazoo on the NASA site. Only SpaceX has the capability of maybe getting us there in 10 years. If we can't denigrate NASA without losing a lot of friends. But realistically, NASA's not going to get us to Mars. There's no transit hab. There's no, the SLS is unaffordable. They can't build them fast enough to get a heavy lift into low Earth orbit, let alone Mars transit. I'm passionate about this, and to the point of I have to be very careful. I give weekly lectures now where I have to talk about SLS and SpaceX in the same half hour. It's hard.
Well,
yeah, I get that.
Go ahead, Emma.
Sorry, I was just going to say, it may be that we're all trying to give a certain level of education when we start out, when we're first talking to people, to our groups, and we have to give them the basic information first. And maybe that's what we could be centralizing, instead of us all trying to recreate our own ways of doing. Going from your comments earlier as well, Andrea, that you're having to research all of your own materials to be able to put them forward. I mean, there's no doubt there's a whole wealth of educational materials, across all these amazing sites. But what is our pipeline, to go back to what is the Mars Ambassador mission? What is the message that we want to get across to people? And can we centralize something that we could all then dip into and use, or point people to, and then take it from there, once you know what base level knowledge they've been set with?
That's excellent idea. And this is what we're talking about today. I think it's time to start pulling that all together. Roger Gilbertson had created a few forms on the Google form, and they were sent out a while back, but I'll make sure that gets out to you all in the short term here, because we can pool our information. we can learn from each other. Point in fact, we're doing that right now. So just making sure that it's coordinated enough so that we can all benefit from it and we can all add to it and use that level of information to move forward. Everyone here is at a different level of education on the space technologies, the space civilizations, whether it be Mars or the solar system or stellar, whatever we're dealing with, we have different interests. And the reason for the ambassador program is to take those interests and focus them to lift the awareness of the general public within your area of expertise while still sharing the vision of the Mars Society. We can learn from NASA. We can learn from the Planetary Society. I mean, we can learn from the planetarium that Neil deGrasse Tyson runs in New York. We can learn from LA City College, where Dean was a professor for so many years. And definitely we can learn from each other. So this is a very beginning stage, but let's do some work on that individually, and we'll pool it and have something to come up with for the next meeting to share. And in the meantime, we'll get some thoughts to you to share your feelings and maybe give us some feedback.
I just wanted to say too, Emma, you're absolutely right. So I'm an accredited NASA educator, so I get all their stuff and they feed me the resources, okay? But that's just one small component of it. I don't want my kids to be NASA bots. I mean, I want them to grow up and know the basics of what they need to know to get to where they want to go with their career, you know, whatever they want to do. So I'm looking to the Mars Society for something a little bit more maybe innovative and not, I don't want to indoctrinate anyone. I don't want to say this is the NASA plan, this is the NASA track, and this is the, you know what I'm saying? Like, as an educator, that's what they do. They feed you everything. You're trained and then they give you all the resources. But that should be just a small part of it.
Yeah, we are free thinkers. We all have something to offer in our own inimitable style. And point of fact, we are doing that right now. So thank you for your participation. Thank you for your insights, for joining in today. I really appreciate your participation. It's very important for us to have that. You may even want to bring a friend on board next time who may be considering something of this nature so they could participate in their own way. We can learn from everyone, whether they're an ambassador or not, but we as ambassadors, I think, have kind of a duty, if you will, to bring people to the awareness that we are going to Mars. We're about to enter the most extraordinary time in the history of our civilization where we will become a multi-planet species. And that is what we're focusing on. So with that, I thank you from the bottom of my heart for you folks being here today, adding your points of interest. And next month, we'll have even more to share. And I, of course, will be in touch with you. And you definitely need to be in touch with me. So thank you very much. Let's do an over and out. And we will be in touch. Bye now.
All right, bye. Thank you.
Bye.
Good meeting, Jim. Thank you.
Bye.
We'll probably get some information from James Burke also, especially on the Red Planet live podcast coming up next week, Tuesday. So tune into that one.
Yeah.
Thanks again.
Thanks.
Hi, Ginger.
Hi, James. Good to see you.
I'm going to end the program. There we go.